we're going to be talking about powers of 10 and scientific notation. And we're going to start off with looking at a problem such as 10 to the fourth power. If you have 10 raised to a power and the power is positive, like it is here, that number, that exponent, tells you the number of zeros that are going to follow the 1. So 10 to the fourth is equal to 1 followed by 4 zeros. So it's equal to 10,000. 10 to the seventh is equal to 1 followed by 7 zeros. So that would be 10 million. Now, if the exponent is negative, such as in 10 to the negative 6, that tells you the number of decimal places that your answer is going to have. So we'll say number of decimal places. Okay, so 10 to the negative 6, we'll put down 0 and then our decimal place, and we need 6 decimal places, so we're going to count 1, 2, 3, 4, 5, 6, and the last, so it'll be 5 zeros followed by a 1 to make 6 decimal places. Now 10 to the negative 3 is going to have 3 decimal places, so we write down a 0 and our decimal point, and so we write 0, 0, 1 for 1, 2, 3 decimal places. Okay, so now let's say we want to find the value of each power of 10. This is just some more practice. 10 to the negative 8. We're going to write down 0 and a point. We're going to have 8 decimal places. So we've got 1, 2, 3, 4, 5, 6, 7 zeros followed by a 1. 10 to the positive 3 means we're going to have 1 followed by 3 zeros for 1,000. 10 to the 9 means we are going to have 1 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, which gives us 1 billion. 10 to the negative 2. That means we're going to have 2 decimal places, so we have 0 in our decimal point, and so that's 0 and a 1, so 0.01. 10 to the 5th, 1 followed by 5 zeros, so we have 100,000. And then 10 to the 10th means 1 followed by 10 zeros. And putting in our commas every 3 places back. There we have it. Okay. So now, so we've ended up with 10 billion. Let's move on to the next page. We want to write each number as a power of 10, so we're just going to kind of go backwards from what we were doing before. So we have 1 million, that's a 1 followed by 6 zeros, so that's going to be 10 to the 6th power. Next one, 0.0001. So we've got 4 decimal places, so we're going to have 10 to the negative 4. 1,000, we have 3 zeros following the 1, so it'll be 10 to the 3rd. 100,000, we have 8 zeros following the 1, so we're going to have 10 to the 8th. So now next, let's say that we want to find the value of each expression. 23.89 times 10 to the 8th power. If the number is positive, if your exponent is positive, I should say. So positive exponent means move your decimal point to the right. It says decimal point to the right. Okay? And so it's 10 to the 8th, so that means we're going to move our decimal point to the right 8 places. So let's do that. We go 1, 2, 3, 4, 5, 6, 7, 8. We have 6 empty spaces, so we're going to have to put in zeros in those places. So we end up with 2, 3, 8, 9, followed by 6 zeros. So 2,389,000,000. Now, moving on to the next one. 467 times 10 to the negative third power. The negative exponent tells you that you are going to move the decimal point to the left. So let's write that down. Move decimal point to the left. Okay, so 467 has a decimal point at the end of the number. Let's move it to the left 3 places. 1, 2, 3. So we end up with 0.467. Next, 853.4 times 10 to the 5th. We're going to have to move this decimal point 5 places to the right. 1, 2, 3, 4, 5. We have 4 empty places, so we're going to have to put zeros there. And then put in our commas to get 85,340,000. And then for this last one, 0.163 times 10 to the negative 2. Basically what we're going to have to do, because the exponent is negative, we're going to take 0.163 and take that decimal point and move it 2 places to the left. So we're going to end up with 0.00163. Okay? So moving on in summation to what we've just done, multiplying by powers of 10, if the exponent is a positive integer, move the decimal point to the right, as in 125 times 10 to the 5th. The 125 has the decimal point on the end, move it 5 places to the right. So you're going to have 125 followed by 5 zeros for 12,500,000. If the exponent is a negative integer, move the decimal point to the left. So is in 36.2 times 10 to the negative 3. Take the decimal point, move it 3 places to the left. So we will end up with 0.0362. Now that leads us to our next idea, scientific notation. And scientific notation is a method of writing numbers that are very large or very small. It has 2 parts that are multiplied. The first part is a number multiplied by a power of 10. Now the number has to be greater than or equal to 1, but less than 10. And then followed by multiplication by a power of 10. So here are 2 examples, 2.5 times 10 to the 9th. This 2.5 is a number greater than or equal to 1, but less than 10, followed by a power of 10. And then we have 9.37 times 10 to the negative third power. This is another example of scientific notation. The 9.37 is greater than or equal to 1, but less than 10. And then it's multiplied by a power of 10. And it doesn't matter whether the power of 10 is positive or negative. So let's take a look at this. This problem, Saturn has a diameter of about 1.2 times 10 to the 5th kilometers. Its distance from the Sun is about 1,427,000,000 kilometers. Write Saturn's diameter in standard form. So we want to write 1.2 times 10 to the 5th as we would any ordinary number, not in scientific notation. So basically, we're going to take the decimal point and move it 5 places to the right. So we are going to have 12 followed by 4 zeros in this case. So we get 120,000 kilometers. Now moving on to the next problem, it says write Saturn's distance from the Sun in scientific notation. So the distance from the Sun is 1,427,000,000 kilometers. We want to write that in scientific notation. So what we're going to do is we're going to make sure the first number is greater than or equal to 1 but less than or equal to 10. So the trick to doing that is take the very first digit, put a decimal point, and write down the rest of the numbers until you have all zeros. So we're going to write 1.427. That's going to be times 10 to a power, because that's what scientific notation is. And we need to figure out, if our decimal point is between the 1 and the 4, how many places are there between that decimal point and the end of the actual number. So if our decimal point is here between 1 and 4, when I just put it in here, how many decimal places do you need to go to get to the end of the number? And it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 1.427 times 10 to the 9th power. Okay, so there's some examples of scientific notation and powers of 10. And we will see you next time. Thank you for joining me.